Hello, now we are going to look at rectangular solids, and we might also call these things rectangular prisms. So to begin with, our rectangular solids are just going to be like cardboard boxes. They're just rectangular boxes, and that's what we're going to look at the maths of today. Now the reason we might call it a prism is because a prism is where we have a particular surface. If we imagine that this is like a steel bar or something like that, it has a particular shape to the end of it, and then it stays the same shape throughout its length. And that's what we call a prism. And we're going to look at other prisms over time. But for right now, we're dealing with rectangular boxes or rectangular prisms. Now, as always, when we recognize our shape, we're going to say, well, do I know any formulas? Do I know any equations that I can link to here? In this case, it's very similar to the area of a rectangle. It's just we have an extra dimension. So the volume is just going to be the amount of space that the box takes up is going to be the volume, is going to be the length multiplied by the width multiplied by the height. The length multiplied by the width multiplied by the height. And this is only true for our rectangular prisms, for our rectangular boxes. There'll be other ways that we'll have to find volume in the long run for different shapes, but this is true for our rectangular boxes, that just length multiplied by width multiplied by height gives us our volume of our box. The other concept that we can often come across is the surface area. So the surface area means the area of all of the surfaces added together. And for sometimes that will just be a matter of getting the length by the width would give us the bottom and the top of the box. The front of the box, we could have the length times the height. That would give us the area of this surface. This surface here, the front of the box, is just a rectangle. And we know that the area of a rectangle is the length by the width, or in this case, we'd call the length by the height. So we'd multiply the two side lengths together to get the area of our front. And that would also be the area of the back of the box that we can't see. And then the area of the sides would be the width times the height, because again, this is just a rectangle. It's drawn in a kind of a 3D type shape, but this is a rectangle, or it means a rectangle. So we can get the areas of the two sides, the area of the front and back, the area of the top and the area of the bottom. We add all of those rectangular areas together, and that gives us the total surface area, or the surface area. So the surface area of our box is find the area of all of the individual surfaces and add them all up. And that gives us the surface area in total. So that's our surface area. Connected with the surface area, we can be asked to draw a net of something. And a net effectively means if we imagine we had this cardboard box and we took a knife and we cut the corners of it and then laid the box out flat on the desk. So this would be one of the ways that we could lay out our box flat. This is a slightly different shaped box, but we would be able to cut the corners and we would be able to just fold this box out. So we have, say, the front of the box and the top of the box and the back of the box and the base of the box, and then we have the two sides of the box, and we've just unfolded them all so that we can see them lying flat. Now there's nothing that says that this is the only way that we could unfold that box. There's loads of different ways that you could unfold the net of a box, and sometimes you'll be asked to do it in more than one way to show that you understand that. But all we're doing is taking a particular surface, we take a particular anchor, or often the front of the box, and we say, okay, that's the front of our box. And then the next one I'm going to draw, I might draw the top of the box. And then I know that if I keep going around the box, the next one would be behind, and the last one I would draw would be the back of the box. So here would be the back of the box. So by giving yourself an anchor, just saying, well, this is the surface I'm going to start with, you just trace your way around. You just walk your way around the shape, taking into account all of the different surfaces, and we don't forget the sides of the box as we're doing it. So let's get into some number examples. So we have here a box, and we're told that it's 5 meters tall, but 10 meters wide, but 4 meters deep. Find the volume. So V for volume and SA for surface area of the open box. Now this is a very important phrase in these types of questions. What does an open box mean? Well, if we just think about what it means in English. And if we look at the picture, I can see the back corner of this box here as I'm looking down into it. That means that there's no top on the box. There's no lid on the box. So it's an open box. So there's no lid. And obviously that's going to affect the surface area because now there's no top area to the box. So I need to keep that in account. I need to keep that in mind as I'm doing the surface area. It has no effect on the volume, but it does affect the surface area. Now for all of these questions, unless they particularly tell you that the box has thick walls, as in you have to take into account the thickness, you just find the external surface area. So the area of the outside of the box, if they ask you for the surface area. And for the volume, you just assume that the measurements are exactly as they are given to you. You don't need to worry about how thick the walls of the box are, unless they tell you to do so. So let's get into our question now. So let's find the volume. Well, I'm looking at this and I say, well, I have a rectangular solid. I have a rectangular box or a rectangular prism. So I know that the volume of a shape like that is the length by the width by the height. And I know that the length, sorry, I should keeping the naming scheme as we normally use it. The height is 5, the length is 10, and the width is 4. So I have my formula. I've recognized my shape. Everything I can, I've labeled in. I could label in other sides. So I know that they're all 5 meters. I know that up here is 10 meters. I know that back here is 10 meters. If I get stuck in a question, this is one of the ways that I can get myself unstuck, filling in the information that I don't know. And as the questions get more complicated, filling in those pictures, filling in what we know will become even more important. But for right now, we have our formula. We've written down what we know for each piece. So the volume is just going to be the length by the width by the height. So let's keep that in order. So 10 for the length, 4 for the width, 5 for the height. And we end up multiplying them together and getting 200. And this is a volume. I've multiplied 3 lengths together. So length by width by height, they're all in meters. So that means I've multiplied meters together 3 times. So it's meters cubed. So that's my volume. And my surface area now for my open box. So I need to be careful that it's an open box. Well, I'm just going to add up the area of all of the surfaces. Well, what's the area of the front? So I'd have the front plus the back of the box plus the sides of the box plus the base of the box, the bottom of the box. What did I call that? So I'll call this B with a little O for the bottom of the box. And I don't have a top to this box because I know it's an open box. So now I'm going to get the area of all of these, in this case, rectangles. These are just the areas of rectangles. So the front of the box is going to be 5 by 10. That's going to give me the front and the back of the box. It's 5 by 10 and the back of the box is the same. So 5 by 10. The sides of the box are 5 by 4. Again, it's a rectangle, so it's just length by width, 5 by 4. Oops. And I'll add all of this up. So when I've done all of my adding up, and I'm careful that I write this out, I tell myself the story of what I'm doing and I sub in. The reason is that when we get to more complicated questions, this structure will help us hugely in answering the more complicated questions. So we want to do it for the easier ones too. So we're writing down our formula, we're subbing in, we're working it out step by step, and that gives us the structure to succeed in the long term for the harder questions. So I add all of that up and I get 180. And in this case, it's going to be meters squared because these are surface areas. This is the area of a surface, and I know that area is going to be squared. I have length multiplied by length in each case. Now, if we get into a slightly more advanced question, we have a box here, and it's 3 centimeters long, but 2 centimeters wide by 8 centimeters high. And I'm told that the surface area, the total surface area for our closed box, it doesn't say anything about an open box this time, is 82 centimeters squared. So I'm asked to find H and then draw a net of the box. So I know that a net is where I unfold the box. So I need to find out what H is. Well, I know that the surface area is just adding up all of the areas of all of the surfaces, and I know that that must add up to 82. So the surface area is 82, and I know that that comes from adding up the area of each one of these rectangular surfaces. So what's the area of this going to be? Well, it's going to be 2 multiplied by h. So the front of the box, plus the back of the box, plus the sides of the box, plus the bottom of the box, plus the top of the box. So let's find the area of each one of those surfaces, and we know it all adds up to 82. So 2 by h would give me the front of the box. So 2 multiplied by h gives me the front of the box, and the back of the box would be the same. And the sides of the box will be 3 by h. And the bottom of the box is going to be 3 by 2. And the top of the box is going to be 3 by 2. So we add all of that up. And we know that that is going to be equal to 82, because that's what we're told the total surface area is. So now we have an equation to rearrange. So I don't want that 12 there, I want the h's by themselves. So I'm going to remove 12 from both sides. And I can put my dashed line down my equal sign to remind myself I'm keeping the balance. 10h is equal to 70. And I want to know what 1h is. So 10 divided by 10 would give me 1. So I end up with h is equal to 7. And the units here are centimeters. And now I need to draw my net of my shape. That was my other thing I needed to do. So let's draw in the net. We're going to start with the front. I'll just do it freehand. That's going to be h and 2. The bottom of the box is going to be 3 centimeters long, so we make it a bit longer than our 2. That's the bottom of the box done. And now we go up? We'll go up and do the top of the box, and that would be 3 centimeters long as well. And we keep going. So here I've just drawn an example of the net. So I started out with my front here, and I've unfolded the shape, and I decided I'd do the sides in 2 different places. And you need to be careful, this can easily lead to an error, but you can see the way that we have unfolded the shape here. Now let's have a look at converting between liters and centimeters cubed. So this is ways of comparing volume. We use liters in lots of daily activities, and in science we tend to use centimeters cubed. So the key thing to remember is that 1 liter is a box that has sides, or a cube I should say, that has sides of 10 centimeters. So that means 1 liter would be 10 by 10 by 10 centimeters cubed, or 1,000 centimeters cubed. And how could we use that in a question? Well, if they gave us a volume in liters and we had to find a missing side in centimeters, all we would have to do is say, well, our 2 liters that we're given here, we know we're dealing with the volume of a rectangular box. So that means our volume is going to be our length by our width by our height. We know that at the volume is equal to 2 liters. We know that at the height is 40 centimeters, and we know that at the length is going to be 10 centimeters, and we want to know the width. So we write down we have our formula written down, but we have a problem. These are in centimeters, this is in liters. So I know that 2 liters, well, if 1 liter is 1,000, 1 liter is 1,000 centimeters. Multiply both sides by 2. That looks like a squared. Multiply both sides by 2. And I end up with 2,000 centimeters cubed. So I know that the volume is equal to length by width by height, and rearrange. Divide both sides by 400, and the width must be 5 centimeters. And that's what we need for now.